Have you ever wondered what it truly means to be dangerous? On Earth, we measure danger in things we can see and feel. Earthquakes that shatter cities, volcanoes that release rivers of fire, hurricanes and cyclones that twist entire coastlines into ruin, even the silent, invisible threat of a deadly virus that can stop human civilization in its tracks. But in the cosmic stage of the universe, these dangers are nothing more than whispers in the void. The universe does not deal in tremors and storms. It does not settle for wildfires or tsunamis. Out here, danger takes on forms so colossal, so terrifying, and so utterly alien, that our human minds can barely wrap themselves around the scale. To ask, what is the most dangerous thing in the universe, is not just a question of curiosity. It is a question that strikes at the very foundation of existence. It forces us to compare the fragility of life to the raw, merciless powers that govern the cosmos. And as we peel back the layers of stars, galaxies, and the fabric of reality itself, we begin to glimpse truths so unsettling that danger may not even be the right word. It may be annihilation. It may be inevitability. It may be something far worse, the universe, a stage built on violence. The first truth we must accept is that the universe itself was born in violence. The Big Bang, that mysterious instant of creation, was not a gentle unfolding of light, but an explosion of unimaginable energy. Space itself stretched, expanded, and tore apart at speeds faster than light. Matter and antimatter collided in a chaotic storm, destroying each other in flashes of raw power. Only a tiny imbalance allowed matter, the stuff that makes up you, me, and the stars, to survive. From its very first breath, the universe was already dangerous, and it never stopped. Stars are born in clouds of gas so dense that gravity crushes atoms together until nuclear fire ignites. These stars shine for millions or billions of years, but eventually their fuel runs dry. When that moment comes, many stars die quietly, cooling into white dwarfs. But the biggest stars, the giants, die violently. They collapse under their own weight, releasing energy in a supernova so bright it can outshine an entire galaxy. For a brief time, one dying star can rival billions of suns combined. But the danger does not end with the explosion. Sometimes, what is left behind is a neutron star so dense that a teaspoon of its matter weighs as much as a mountain. Other times, the collapse continues, and the star forms something even darker, a black hole. Already, we begin to see candidates for the most dangerous thing in the universe. Supernova can sterilize planets across vast distances. Neutron stars spin so fast and emit such radiation that they could tear apart anything that comes too close. Black holes consume everything like matter, even the very concept of information itself. And yet, these are just the beginning. What does dangerous mean? Before we dive deeper, we need to pause and ask, how do we even define danger? On Earth, danger is something that threatens life. A predator lurking in the shadows, a poison coursing through the veins, a storm that takes away the breath of the sky. But on a universal scale, danger must be redefined. Out here, danger is not about intent. It is not about choice. The universe is not malicious. It simply is. So danger becomes a matter of power. The power to destroy life, the power to erase entire worlds, the power to dismantle galaxies, or perhaps even unravel reality itself. With this in mind, we will journey through the universe's most terrifying phenomena. Some are natural, born of stars and physics. Others are mysteries we barely understand, like silent shadows lurking at the edge of human knowledge. Each one is a contender for the title, the most dangerous thing in the universe. Gamma-ray bursts, the universe's deadliest beams. Imagine this. You are standing on Earth, looking up at the night sky. Suddenly, without warning, a star, millions of light years away, dies. But this is no ordinary death. As the star collapses, it focuses its energy into two narrow beams, like the barrels of a cosmic gun. These beams slice through space at nearly the speed of light, carrying radiation so intense that it could strip the atmosphere from an entire planet in seconds. This is a gamma-ray burst. For years, scientists struggled to understand them. Some believed they were signals from alien civilizations. Others thought they were anomalies in the data. But eventually, we discovered their terrifying truth. They are the most powerful explosions known in the universe since the Big Bang itself. A gamma-ray burst can release more energy in a few seconds than our sun will emit in its entire lifetime. If such a burst ever struck Earth directly, it would be catastrophic. The upper atmosphere would be shredded, the ozone layer destroyed. Radiation would bombard the surface, wiping out ecosystems and sterilizing vast regions of the planet. Humanity, along with nearly every other form of life, would face extinction. The terrifying part: gamma-ray bursts are not rare. They happen often scattered across the universe, like fireworks of death. We just happen to live in a quiet corner of the galaxy, where none have struck in recent memory. But cosmic time is long. One day, a burst may point directly at us. Is this the most dangerous thing in the universe? Perhaps, but it is not the only contender. Black holes, the cosmic predators. Black holes are perhaps the most famous monsters of the cosmos. Born from the death of massive stars, they are regions of space where gravity has grown so strong that not even light can escape. To cross the event horizon of a black hole is to fall into a place where space and time themselves break apart. But black holes are not simply cosmic vacuum cleaners, sucking up everything nearby. Their true danger lies in their unpredictability and their scale. A small black hole just a few times the mass of our sun might only affect its immediate surroundings. But supermassive black holes, the kind that sit at the hearts of galaxies, can weigh millions or billions of suns. Their gravitational influence shapes entire galaxies, pulling stars into orbit like moths circling a flame. If Earth were to drift too close to a black hole, the results would be horrifying. First, tidal forces would tear the planet apart in a process scientists call spaghettification. The pull of gravity on one side of your body would be far stronger than on the other, stretching you into a thin strand of matter. Entire planets, stars, and even clusters of stars can be shredded this way, their remains spiraling into the abyss. Yet, even this might not make black holes the ultimate danger. After all, they remain relatively rare, scattered across galaxies, and most of them are far from us. Still, black holes hide secrets. Some scientists believe they may not simply destroy information, but warp it, perhaps even connecting different regions of the universe through hypothetical wormholes. Others suspect that in their depths lies the key to understanding the very fabric of reality. And if that is true, then black holes may hold dangers we cannot yet imagine. The invisible killers, dark matter and dark energy. When we look at the universe, we see stars, galaxies, nebulae, and planets. But all of this, the stuff we call normal matter, makes up less than 5% of the cosmos. The rest is something else entirely. something invisible, untouchable, and poorly understood. Roughly 27% of the universe is made of dark matter. We cannot see it, but we know it must exist. Galaxies spin too fast to be held together by visible matter alone. Something unseen is providing the gravity that keeps them from flying apart. This invisible glue, this ghostly presence, surrounds galaxies like a halo. But what is dark matter? We don't know. It does not emit light, nor does it absorb it. It slips through matter as if it isn't there. Yet it shapes the structure of the universe on the largest scales. Could dark matter be dangerous? Imagine if some interaction we have not yet discovered suddenly destabilized it. If dark matter were to decay or react in a violent way, the very fabric of galaxies, including our own, could unravel. Entire clusters of stars could fall apart. The danger of dark matter lies not in what we know, but in what we do not know. Even more terrifying is dark energy. Making up about 68% of the universe, dark energy is the mysterious force causing the cosmos to expand at an accelerating rate. Left unchecked, this acceleration could one day tear galaxies apart, then solar systems, and eventually even atoms themselves, in a scenario scientists call the Big Rip. Imagine a future where space itself stretches so violently that nothing, not even the bonds holding particles together, can survive. That, perhaps, is the ultimate danger. A universe that destroys itself from within. The fragility of life when we think of these cosmic dangers, gamma-ray bursts, black holes, dark matter, and dark energy, becomes clear how fragile life really is. Humanity clings to a tiny rock orbiting an average star in an ordinary galaxy. The universe is vast, ancient, and indifferent. At any moment, without warning, a force beyond comprehension could erase us, and yet, somehow, life persists. We are here, staring into the cosmos, asking these questions. Perhaps that persistence, that spark of curiosity, is our greatest defense against danger. But still, the question remains, what is the most dangerous thing in the universe? So far, we have only scratched the surface. The candidates we've explored are terrifying, but they are not the end of the story. There are other dangers, hidden ones, stranger ones, and perhaps ones that do not even exist yet, but could emerge in the future. Danger in the universe is not always obvious. Sometimes it hides in silence. The night sky appears peaceful, sprinkled with stars like glowing dust scattered across a black canvas. But every point of light hides a story, and some of those stories are nightmares written in physics. If we strip away our human perspective and look at the cosmos as it truly is, we find a place that is not made for life at all. It is made of extremes of temperature, gravity, radiation, and emptiness. And in these extremes lie dangers, so overwhelming that the very existence of anything as delicate as life seems almost miraculous. Consider the vacuum itself. We imagine empty space as harmless, a place where nothing happens. But true emptiness is hostile. Without an atmosphere, without pressure, the human body would swell as gases inside expand. Water in tissues would boil away, and consciousness would fade within seconds. Space is death, not because of what it contains, but because of what it lacks. It is an eternal void that strips away heat, air, and life in silence. And yet, that is the very environment where everything exists. Life lives on fragile islands, planets, with atmospheres, adrift in oceans of lethal nothingness. But even planets, these rare sanctuaries, are not safe. Every world is exposed to the fury of its star. Stars are givers of life, but they are also destroyers. Our sun bathes Earth in light and warmth, but hidden within its glow are flares and coronal mass ejections, storms of charged particles hurled across space. A powerful solar flare could fry electrical grids, strip away satellites, and render technology useless in an instant. Stronger ones, the kind we suspect young suns unleash, could strip entire atmospheres, turning once habitable planets into barren deserts. Mars may have been such a place, losing its protective magnetic field and watching its oceans vanish into the void under the relentless pressure of solar wind. Multiply this danger across the billions of stars in the galaxy, and you begin to see a truth: survival is rare. Every planet must withstand cosmic bombardment, not just from its star, but from asteroids and comets as well. Earth bears the scars of ancient impacts, craters carved deep into its crust. 65 million years ago, one such rock struck our planet and ended the reign of the dinosaurs in a single catastrophic moment. Had it been larger, Earth itself might have been sterilized. Out in the asteroid belts and icy regions of the solar system lie countless such projectiles, waiting silently in orbit, their paths vulnerable to tiny nudges that could one day aim them directly at us and beyond our solar system. Even greater dangers lurk. Imagine a rogue planet worlds, ejected from their home systems, wandering the galaxy alone. With no sun to warm them, they are frozen spheres of rock and ice, invisible in the darkness. Should such a rogue planet drift into our solar system, it could destabilize orbits, fling Earth into deep space, or trigger a cascade of gravitational chaos. We like to imagine our solar system as stable, but in the grand cosmic scale, nothing is permanent. Everything moves, shifts, and collides in the slow dance of gravity. Still, all of these dangers, asteroids, solar flares, rogue planets, feel small compared to the titans of energy that rule the larger universe. Consider again the gamma bursts, those deadly beams of light that outshine galaxies. We know they exist, but we do not know when or where the next one will erupt. It is a lottery of extinction, and we hold a ticket whether we like it or not. A burst even thousands of light years away, if pointed directly at Earth, would erase the ozone layer, flood the ground with radiation, and ignite global chaos. The frightening part is not just their power, but their silence. There would be no warning. By the time the beam reached us, it would already be too late. Yet even gamma-ray bursts pale before the raw, crushing violence of black holes. Imagine drifting too close to one, pulled into its invisible grip. From a distance, you would see stars bend and twist around its horizon, light curving into eerie spirals as if reality itself were warped. Get closer, and you would feel the unimaginable. Your body would be stretched thin, every atom pulled apart, in a process so strange and cruel that we gave it a grotesque name: spaghettification. Not even planets or stars are safe. A black hole can shred them, tearing their substance into glowing disks of fire as matter falls inward. But perhaps the most disturbing truth about black holes is not what they destroy, but what they hide. We do not know what lies at their centers. The equations break down, and our understanding collapses with them. Inside may be singularities, points of infinite density, or perhaps gateways to other universes. Whatever they are, they represent the limits of our knowledge. And in those limits, danger thrives. If we step back further still, to scales beyond galaxies, we face the silent tyrants of existence, dark matter and dark energy, the first, unseen, but essential, holds galaxies together. The second, mysterious and relentless, pushes them apart. Dark energy is accelerating the expansion of the universe, faster and faster as time goes on. If it continues unchecked, the cosmos faces a violent future. Galaxies will drift away from one another until they disappear beyond each other's horizons. Then, in the far future, space may expand so violently that stars are torn from galaxies, planets torn from stars, and atoms torn apart. This ultimate unraveling has a name: the Big Rip. It is a future where danger does not come from an external source, but from the very structure of reality itself tearing itself apart. And yet, perhaps none of these things, no black hole, no gamma ray burst, no dark energy, are as dangerous as the illusions of stability that life clings to, because the greatest danger may be the inevitability of time itself. Stars burn out, galaxies fade, even black holes evaporate, leaking away through the slow hiss of Hawking radiation. Nothing is eternal. The universe does not preserve, it only transforms. In the farthest reaches of time, every light will go out, and every atom will decay into nothing. If danger is the threat of ending, then perhaps the universe itself is danger embodied, for it promises that all endings are not only possible, but guaranteed. And so we return to the question: what is the most dangerous thing in the universe? Is it a single phenomenon, a burst of deadly light, a monstrous black hole, a creeping tide of dark energy? Or is it something broader, more inevitable, more fundamental? The truth may be that the most dangerous thing is not any one object or event, but the very nature of existence itself. That life is fragile in a cosmos that does not care. But we are not finished, for there are other shadows, other strange whispers from the edge of knowledge that suggest dangers we can barely comprehend. Phenomena so theoretical, so elusive, that they may never come to pass, or, terrifyingly, they may already be unfolding without us knowing. To explore them is to dive deeper into the mystery, and to realize that what we fear most may not yet be known. And as we probe further into the universe's most hidden dangers, we encounter objects so strange that they almost defy logic. Take magnetars, for instance, rare types of neutron stars with magnetic fields billions of times stronger than anything we can produce on Earth. These are not just strong, they are universe-shattering. A magnetar could erase the magnetic field of a planet from thousands of kilometers away, bending metal, disrupting electronics, and even twisting the very atoms themselves. Stand too close, and the forces would rip your body apart at a molecular level, leaving nothing behind. Their flares can release more energy in a single second than our sun will emit in hundreds of thousands of years. And yet, they are few, scattered across the galaxy, silent until the moment they erupt, reminding us that the universe often keeps its deadliest weapons hidden until it chooses to reveal them. Then there are the rogue black holes, travelers of the void that wander between star systems, unseen and untracked. Most black holes are tethered to galaxies, their gravity shaping countless orbits. But a rogue black hole drifts alone, unbound, a predator with no patterns. Imagine one silently crossing through our solar system. Planets would be thrown from their orbits, the sun's gravitational dominance disrupted, and chaos would reign on a scale no human has ever imagined. The Earth could be cast into eternal darkness, flung into a trajectory far from our life-giving star, with no hope of returning. And yet, we might not even know it until the very moment destruction begins. Even stranger are the theoretical dangers hinted at by the edges of physics. Strangelets, tiny hypothetical particles of exotic matter could theoretically transform normal matter into more of themselves upon contact. A single rogue strangelet could start a chain reaction, converting entire planets or marine to something unrecognizable, while no such event has ever been observed. The mere possibility reminds us that danger does not always follow the rules we understand. The universe is not obligated to play by human expectations, and perhaps the ultimate lesson of all these dangers is humility. Humanity, perched on a small, fragile planet, is surrounded by forces that operate on scales of energy and time we cannot truly comprehend. Every star that twinkles in the night sky is a reminder of creation and destruction. Every comet that streaks across the darkness is a messenger of inevitability. And every moment, every second that life persists is a defiance of the cosmic rules that could easily erase it. Beyond the stars that we can see, and beyond the violent deaths of suns, the universe harbors dangers that are both subtle and pervasive. Some of the deadliest forces are not explosive or visible. They are slow, invisible, and patient. One of these is cosmic radiation, a silent rain of particles that travels across galaxies at nearly the speed of light. Most of it is harmlessly deflected by Earth's magnetic field, but consider a planet without such protection, drifting alone in space. Every second high-energy particles would bombard its surface, slowly breaking apart molecules, mutating DNA, and sterilizing life. Over millennia, even the strongest forms of life would succumb to this invisible siege, leaving behind a world that is lifeless, irradiated, and forgotten. Time, too, is a subtle yet inexorable danger. On human scales, 1,000,000 years is nearly incomprehensible, but on cosmic scales, it is a fleeting moment. Stars live, age, and die. Galaxies collide, merge, and reshape. Entire regions of the universe are erased and reborn over epochs so long that consciousness cannot follow them. And even as life endures, the passage of time is relentless. Planets drift from habitable zones, suns brighten or dim, orbits destabilize. What seems permanent is only temporary, and survival is never guaranteed. The universe does not pause for us to catch up. It continues its processes with perfect indifference. There are also dangers hidden in the fundamental laws themselves, the forces that hold matter together. The strong and weak nuclear forces, electromagnetism, gravity, are finely balanced. A slight change in any of these constants, and atoms might collapse, stars might fail to ignite, and life, as we know it, could never exist. Some physicists have theorized that even in the vast cosmos, there may be regions where these constants differ. Enter such a region unknowingly, and your very matter might disintegrate or fail to function. The most dangerous threats, then, may not be objects or events, but the very fabric of reality itself. Yet, the universe has even stranger surprises in store. There are objects known as rogue planets and brown dwarf worlds that failed to ignite into stars, wandering in the darkness, cold and lonely. These planets are invisible against the black canvas of space. If one were to drift into a solar system, its gravity could destabilize planets, sending them hurtling into chaotic orbits, possibly colliding with one another or being flung into the void. Even a seemingly harmless, wandering mass can become a silent predator, disrupting order without a sound. Beyond even these, there are the theoretical constructs that challenge our imagination. Quark stars, hypothetical forms of dense matter beyond neutron stars, could weigh the mass of millions of suns in the size of a city, exerting forces that would tear apart planets at a distance. Strangelets particles that could transform ordinary matter into exotic forms might exist quietly, waiting for a chance to trigger a chain reaction across worlds. Wormholes, if they exist, may connect distant regions of space or trap anything that ventures inside forever. Some of these dangers remain speculative, yet they remind us that the universe's limits are far beyond human understanding. Even the phenomena we can see are deadly in ways subtle and grand. Supernova, which explode with the brightness of billions of suns, scatter matter across light years. These explosions seed the cosmos with elements, yes, but their radiation can also sterilize entire star systems. Imagine a civilization orbiting a star that suddenly dies in a supernova. Life could be extinguished in minutes, leaving only ruins of their existence scattered across space. And even if the blast does not reach them directly, the shock waves, gamma radiation, and cosmic rays are enough to erase almost all life within a certain radius. Black holes remain perhaps the ultimate emblem of cosmic danger. The supermassive ones at the centers of galaxies do not simply consume, they dominate. Their gravitational influence shapes orbits, funnels matter, and governs the very structure of galaxies. Stars orbit them, sometimes in perfect harmony, other times in chaotic spirals leading to destruction. And when a black hole merges with another, the collision releases gravitational waves that ripple across space-time, shaking distant stars and planets with forces we cannot even perceive directly. Such events occur constantly across the universe, silent in the void, yet powerful beyond comprehension. But there is also danger in emptiness itself. Interstellar space may appear calm, but the vacuum is a realm of extremes. Temperatures can drop to near absolute zero, yet radiation from distant stars still penetrates, carrying energy that can slowly erode matter over millennia. Charged particles, cosmic rays, and high-energy photons move invisibly. Invisible killers that shape worlds and slowly alter chemistry. Even empty space is a battlefield, and survival is a temporary concession. The universe's danger is not confined to matter. The fabric of space-time itself may hide perils. Ripples and fluctuations, remnants of the Big Bang, may persist as invisible currents across the cosmos. Some theories suggest that the vacuum of space is metastable, meaning that it could, in principle, shift to a lower energy state spontaneously. If this vacuum decay occurs, it would propagate at the speed of light, destroying atoms, stars, planets, and even altering the laws of physics themselves. No one would see it coming, and no one could survive it. In an instant, the universe could be rewritten, leaving nothing recognizable behind. And as we examine these threats, a pattern emerges. The most dangerous forces are often those we cannot see or anticipate. Unlike a storm on Earth, which is loud and observable, the universe's true hazards are silent, patient, and immense. They work on scales of energy, mass, and time that are almost impossible to imagine. Life survives not because danger is absent, but because the universe has chosen, by chance, a corner of existence where extreme forces are kept at bay, at least for now. Yet, even in this corner, danger persists. The sun is not eternal. It will burn through its fuel in roughly 5 billion years. The Earth, currently protected by magnetic fields and atmosphere, is not immune to impacts from comets or asteroids. Cosmic radiation penetrates, slowly altering life. Even the processes that allow our planet to exist, plate tectonics, climate stability, orbital mechanics, are fragile balances. Disrupt any one of them, and survival becomes impossible. The more we study the universe, the more we realize that danger is not an anomaly but a fundamental characteristic. It is woven into the very structure of reality, in the rules that govern particles, stars, galaxies, and space-time itself. From the microcosm of atoms to the macrocosm of galaxies, the universe is a place of relentless forces, subtle threats, and staggering energies. And yet, in the face of this endless danger, life persists. Humanity, perched on a fragile rock in a vast, indifferent cosmos, continues to exist, explore, and imagine. Every breath we take, every star we observe, every discovery we make is a testament to resilience against odds that are incomprehensible. Survival is temporary, fleeting, and uncertain, but it is extraordinary. Perhaps this is the ultimate danger and wonder intertwined, that life exists at all. In a universe designed not for preservation but for transformation, decay, and destruction, every star, every black hole, every gamma-ray burst, every quantum fluctuation is a reminder that danger is not distant, it is intrinsic. And yet, against this backdrop of chaos, consciousness arises, curiosity persists, stories are told, we measure, we explore, we understand in the end. Perhaps the most dangerous thing in the universe is not a star, a black hole, or a burst of radiation. Perhaps it is the universe itself, infinite, indifferent, unpredictable, and relentless. It offers no promises, no protection, and no mercy. And yet, somehow, within this endless expanse of danger, we exist. That is both terrifying and miraculous. The universe has a rhythm, a pulse, that is both ancient and merciless. Every star that ignites is a testament to creation, and every star that dies is a reminder of destruction. But danger is not confined to the extremes of birth and death. It exists in the quiet in-between, in the spaces where we least expect it. Even a seemingly stable star can harbor peril. Our sun, serene from our vantage point, is capable of flares and eruptions that would devastate unprotected technology and life. And beyond our solar system, there are stars in binary systems locked in gravitational jewels. One may siphon matter from the other, creating accretion disks of unimaginable heat and radiation, sometimes producing X-ray binaries that shine brighter than entire galaxies. The delicate balance of life is maintained only through distance and chance. Planets orbiting stars must remain within habitable zones, where warmth is sufficient for liquid water but not enough to scorch the surface. Tilted orbits, eccentric paths, or sudden changes in stellar behavior could render these worlds sterile in an instant. Even within the apparent safety of our solar system, comets, asteroids, and meteoroids continuously traverse space, reminders of the randomness of survival. Earth itself is scarred by impacts, ancient craters marking moments when life's continuity was almost shattered. One might argue that life persists only because these deadly events are rare. But rarity is not safety. It is an illusion, a brief reprieve from the universe's relentless dangers. We look to the heavens and see stars, but between them lies a vacuum that is anything but empty. The space between stars is filled with cosmic rays, high-energy particles, accelerated by supernova and other violent events. These particles move at nearly the speed of light, and, if they strike a planet's atmosphere, can damage DNA, spark chemical reactions, and slowly degrade the conditions necessary for life. Radiation is silent, invisible, and persistent. It does not announce its presence with flashes or alarms. It seeps into existence, slowly, relentlessly, reshaping and destroying at a molecular level. Even without catastrophic events like supernova or gamma ray bursts, life must contend with these invisible predators. And then there are black holes, the ultimate predators of space. Their gravity warps reality itself. Near a black hole, time slows, space stretches, and light bends. Cross the event horizon, and nothing can escape. Not matter, not light, not information, for massive black holes at galactic centers. Entire solar systems orbit in a delicate balance, unaware of the monstrous gravitational forces that dominate their lives. When black holes collide, they send ripples through space-time, gravitational waves that pass through the universe, imperceptible to human senses, but immense in power. The universe is full of these silent catastrophes, events whose consequences span millions of light years, yet go unnoticed by those not in their direct path. Some dangers are not visible or material at all. Dark energy, the mysterious force driving the universe's expansion, could eventually lead to a scenario known as the Big Rip. If its effect continues unchecked, it will stretch galaxies apart, pull stars from orbit, and eventually tear molecules and atoms themselves apart. Unlike gamma ray bursts or black holes, which destroy locally, dark energy threatens everything simultaneously. It operates on a scale so vast that it is almost impossible to imagine. A cosmic tide that slowly but inexorably dismantles the universe itself. Even more subtle is the danger posed by time. Stars have lifespans measured in billions of years. Planets orbit for eons, but eventually, change is inevitable. Our sun will expand into a red giant, consuming Mercury, Venus, and perhaps even Earth. Its death is inevitable, and with it, the delicate balance that allows life on our planet will vanish. Time is the silent killer, impartial and absolute. It reshapes the universe with patience and persistence, indifferent to the fleeting existence of civilizations, worlds, and stars. There are also rogue celestial objects, planets and stars cast adrift from their systems. A rogue planet could pass through a solar system, destabilizing orbits, colliding with worlds, or even capturing moons in its gravitational pull. These wandering objects are invisible threats, moving silently through space, unpredictable and untraceable until their effects are catastrophic. And rogue black holes, equally silent, could wander into star systems, devouring anything that comes near. The universe is filled with these drifters, patient hunters that wait for the right alignment to unleash destruction beyond the physical. There is theoretical danger that may be even more terrifying. Strange letters, hypothetical particles composed of exotic quark matter could, in theory, convert ordinary matter into more strange matter upon contact. A single rogue strangelet could begin a chain reaction, consuming planets, stars, or even entire galaxies. Quantum fluctuations and vacuum decay are other theoretical hazards. Invisible events that could ripple across space-time, fundamentally altering the laws of physics and annihilating everything we know. These are dangers not just of destruction, but of transformation, where the universe itself could change in a way that is utterly incomprehensible. And yet, life has emerged and persisted despite these forces. Humanity, perched on a tiny rock in an immense, indifferent universe, continues to exist. Every heartbeat, every breath, every thought is a defiance of the universe's relentless dangers. We survive not because the cosmos is benevolent, but because chance has allowed a rare corner of existence where life can flourish. Yet survival is not a guarantee. At any moment, Events beyond comprehension could erase us. A nearby burst, a shifting orbit, a catastrophic solar flare could undo eons of life in an instant. The most dangerous thing in the universe, then, may not be a single object or phenomenon. It is the totality of the cosmos itself, immense, indifferent, and filled with forces that can annihilate, warp, or transform reality. The universe is a constant reminder that existence is fragile, temporary, and contingent. Stars die, planets drift. Time marches relentlessly forward. Even space itself may one day unravel in ways we cannot predict. And yet, in the face of this, consciousness exists. Life persists. We look at the stars, imagine the impossible, and confront the dangers with curiosity and courage. Perhaps that is humanity's unique response to the universe's perils, not to conquer, but to understand, not to avoid, but to observe. Every discovery, every exploration, every calculation is a way to map danger, to measure it, and to find safety in knowledge. But the universe remains unconcerned with our survival. It is patient, relentless, and absolute. For every moment we persist, danger continues to exist in countless forms, both visible and hidden. The cosmos is a stage where destruction is as natural as creation, and where the ultimate threat may be the inevitability of change itself. Life is temporary, fragile, and fleeting, but it is also extraordinary precisely because it exists amidst infinite peril. As we delve further into the universe's tapestry, we realize that danger is not merely externally, is intrinsic to the very laws of existence. Stars, for all their brilliance, are volatile engines of destruction. Their nuclear furnaces churn relentlessly, fusing atoms and releasing energy in torrents we can barely comprehend. When a star exhausts its fuel, it does not fade quietly. It may explode in a supernova, a cataclysm that outshines entire galaxies for brief moments. These explosions are both creative and destructive, scattering the elements necessary for life, while simultaneously obliterating anything in their immediate vicinity. Any planet within reach of such an event would be sterilized instantly, reduced to scorched rock and ash. Neutron stars, the remnants of these explosive deaths, carry danger in a compact form. A teaspoon of neutron star material would weigh billions of tons on Earth, so dense that gravity itself behaves strangely near it. Many neutron stars are pulsars, spinning at hundreds of rotations per second, emitting focused beams of radiation that sweep across space like lighthouses. Encounter one of these beams, and it would strip the atmosphere from a planet, fry living organisms, and obliterate electronics. Even at vast distances, the radiation can affect planetary chemistry, alter atmospheres, and disrupt life's fragile balance. Magnetars, an even rarer class of neutron stars, amplify this danger to nearly unimaginable levels. Their magnetic fields are trillions of times stronger than Earth's, capable of warping atoms and bending light. A flare from a magnetar, if directed toward a planet, could strip its atmosphere from thousands of kilometers away, disrupt the magnetic field, and devastate all life. These cosmic titans serve as reminders that danger does not need to be common to be catastrophic. Even a single event, rare as it may be, could erase civilizations or sterilize worlds entirely. Then there are gamma-ray bursts, silent and invisible assassins traveling across the cosmos at nearly the speed of light, arising from collapsing massive stars or merging neutron stars. These bursts release energy equivalent to billions of suns, concentrated into narrow beams. A planet struck directly would have its atmosphere destroyed, its surface irradiated, and all life wiped out almost instantly. These events are unpredictable, indifferent, and universal in scale. A civilization could flourish for millennia, only to be annihilated in seconds by an unseen burst from across the galaxy. Black holes, the universe's ultimate predators, are both invisible and absolute. Their gravity warps space-time itself, bending light and stretching matter into long filaments. Cross the event horizon, and no return is possible. Matter is consumed, information erased, and reality itself is contorted. Supermassive black holes at the centers of galaxies exert influence over millions of stars, dictating orbits and shaping cosmic structures. When black holes collide, gravitational waves ripple across space-time, shaking distant stars and bending the fabric of the universe itself. These waves, though imperceptible to the senses, are manifestations of the universe's raw, unfathomable power. Dark matter and dark energy introduce a subtler, but equally profound, danger. Dark matter, invisible yet pervasive, holds galaxies together, shaping their structure and influencing stellar motion. If its properties were slightly different, entire galaxies might collapse or disperse, destabilizing star systems and extinguishing life. Dark energy, responsible for the universe's accelerated expansion, could ultimately lead to the Big Rip, where galaxies, stars, planets, and even atoms are torn apart as space-time stretches beyond limits. The scale of these dangers is beyond imagination. They operate not locally, but universally, indifferent to civilizations, planets, or stars. Even the vacuum of space is deceptive. It appears empty, but quantum fluctuations and zero-point energy hint at a restless substrate. Invisible and silent, these fluctuations could, theoretically, trigger vacuum decay, a catastrophic event that propagates at light speed, annihilating everything in its path and fundamentally rewriting the laws of physics. Such threats underscore a chilling truth. Danger is not limited to observable phenomena. Some of the universe's deadliest forces may remain hidden, imperceptible until it is too late. Time itself is a relentless hazard. Stars age, planets drift, and galaxies evolve. The universe is governed by entropy, ensuring that order eventually decays into disorder. Even civilizations that avoid cataclysms face eventual extinction due to the inexorable progression of cosmic time. Our sun will exhaust its fuel, expanding into a red giant that will consume Mercury, Venus, and potentially Earth. The universe, in this sense, is both patient and merciless. Destruction does not need to be immediate to be inevitable. Rogue objects also pose an extraordinary threat. Planets ejected from their home systems, drifting through the void, can destabilize entire star systems. A rogue black hole could wander silently into a solar system, devouring planets or flinging them into cold, empty space. Even minor shifts in a star system's dynamics, caused by these wandering masses, can trigger catastrophic collisions or send planets hurtling toward their stars. The universe is filled with these hidden predators, moving silently through the darkness, invisible until their effects are felt. The fragility of life itself underscores the danger inherent in existence. Planets must maintain precise conditions for life to thrive. Appropriate distance from a star, stable orbits, protective magnetic fields, and favorable chemical composition. Deviations in any of these factors could render a world sterile. Earth has survived countless near-catastrophic impacts, supervolcano eruptions, and massive climatic shifts. But survival is not guaranteed. Life exists, because of improbable alignments and rare conditions, constantly threatened by the universe's indifferent forces. Even the smallest particles of matter may conceal catastrophe. Strangelets, hypothetical forms of quark matter, could convert ordinary matter into exotic matter upon contact, initiating a chain reaction that spreads across planets, stars, or even galaxies. Exotic events in particle physics, while largely theoretical, highlight the subtle and unexpected dangers that exist on scales invisible to our senses. The universe's deadliest forces often operate in ways humans cannot perceive directly, challenging our assumptions about safety and survival. Yet, amid all these threats, life persists. Humanity exists on a small, fragile planet in a vast and indifferent cosmos. Every heartbeat, every act of observation, and every exploration is a defiance of forces that could annihilate us in moments. Knowledge itself becomes a tool for survival, allowing us to predict solar flares, track asteroids, and understand stellar evolution. Yet, even knowledge has limits. The universe conceals dangers beyond our comprehension, operating on scales of energy, mass, and time that challenge imagination. Ultimately, the universe teaches humility. Its dangers are not malevolent. They do not target civilizations or planets. They are indifferent, absolute, and inevitable. Gamma ray bursts do not discriminate. Black holes do not pause. Dark energy expands relentlessly. Time erodes all. Survival is temporary. Life is fleeting, and knowledge is finite. Yet, in this indifference lies a paradoxical beauty. Life exists, consciousness arises, and we explore precisely because survival is improbable. The universe, with its countless perils from neutron stars and magnetars to black holes, gamma bursts, and the slow erosion of time demonstrates that danger is universal, patient, and absolute. Yet, within this dangerous expanse, life has carved out a fragile niche, defying the odds. Humanity's existence is a brief, improbable triumph against forces that dwarf comprehension. The most dangerous thing in the universe may not be a single star, planet, or phenomenon. Perhaps it is the universe itself, infinite, indifferent, and relentless in its capacity for destruction. And yet, despite the danger, wonder persists. We look at the stars, measure cosmic phenomena, and imagine what lies beyond. We confront danger with curiosity, courage, and knowledge, understanding that survival is temporary but extraordinary. Every act of discovery, every exploration, every attempt to understand the cosmos is an assertion of life against an indifferent universe. The universe may be filled with danger, but it is also a place where life, however fragile, exists, observes, and contemplates the infinite. As we gaze deeper into the cosmos, the scale of danger becomes almost incomprehensible. Entire galaxies drift silently through space, each filled with billions of stars, and countless more planets, some with life, most barren. Yet within this vast expanse, peril is everywhere, even when invisible. Cosmic rays, high-energy particles, accelerated by supernova and other violent events, traverse the void at nearly the speed of light. They are silent assassins, capable of altering atmospheres, disrupting planetary chemistry, and damaging DNA. Over millions of years, their impact on life is profound, even on planets with magnetic fields or atmospheres that provide partial shielding. The universe itself becomes an unending bombardment of subtle, persistent danger. Black holes, already among the most feared objects, come in a variety of forms. Stellar mass black holes form from collapsing massive stars. Supermassive black holes, millions or billions of times the mass of our Sun, anchor the centers of galaxies, shaping their very structure. Intermediate black holes, still largely theoretical, may lurk in star clusters, unnoticed. Each type represents a different facet of danger. A stellar mass black hole can devour a planet or a star, invisible until it exerts its gravitational pull. Supermassive black holes can destabilize entire star systems, and their mergers release gravitational waves that stretch and compress space-time across unimaginable distances. Even light itself cannot escape their grasp, rendering them invisible predators in the cosmic darkness. Magnetars exemplify the universe's extremes. A magnetar's magnetic field is trillions of times stronger than Earth's, capable of twisting atoms and even distorting the fabric of space. A single flare could strip a planet's atmosphere from tens of thousands of kilometers away, disrupt electronics, and irradiate everything in its path. While rare, their power illustrates that the deadliest dangers need not be frequent to be catastrophic. One flare, one event, could erase entire civilizations, leaving no trace of their existence. Gamma-ray bursts are equally terrifying. These narrow beams of high-energy radiation travel at nearly the speed of light, capable of sterilizing planets across thousands of light-years. They arise unpredictably from collapsing massive stars or colliding neutron stars. A civilization could thrive for millennia, only to be obliterated in seconds by a burst from across the galaxy. Unlike other cosmic threats, gamma-ray bursts strike without warning, their lethal energy invisible until it is too late. They remind us that survival in the universe is often a matter of chance as much as preparation. The universe also hides danger in forces we barely perceive. Dark energy, the mysterious driver of cosmic expansion, could eventually lead to the Big Rip, stretching galaxies, stars, planets, and atoms beyond recognition. Dark matter, though invisible and weakly interacting, dictates the structure of galaxies. A slight deviation in its behavior could destabilize stellar systems, sending planets adrift. Even the vacuum of space, appearing empty, may conceal fluctuations that trigger catastrophic events. Quantum fluctuations, or vacuum decay, could propagate at light speed, annihilating matter and fundamentally altering physical laws. Some of the universe's deadliest threats are invisible, operating silently across unimaginable scales. Time itself is a silent predator. Stars burn, age, and die. Planets drift in unstable orbits. Galaxies collide and merge. Entropy guarantees that order eventually decays into chaos. Even if a civilization avoids catastrophic events like gamma-ray bursts or supernova, it cannot escape the slow, inevitable erosion of time. Our Sun, in a few billion years, will exhaust its fuel, expanding into a red giant and potentially consuming the inner planets. Even the most stable systems are subject to the patient, relentless march of cosmic change. Time does not destroy violently but inexorably, ensuring that nothing lasts forever. Rogue celestial objects further amplify the universe's danger. Wandering planets, stars, or black holes can intrude on star systems, destabilizing orbits, colliding with planets, or ejecting worlds into interstellar space. Even seemingly minor shifts can trigger catastrophic consequences, underscoring that danger is not always visible, predictable, or local. The universe's hazards are often subtle, cumulative, and unavoidable. Survival requires not only awareness, but also extraordinary fortune. Life itself, fragile and improbable, thrives against these odds. Our planet exists because countless conditions aligned perfectly: the right distance from the sun, a protective magnetic field, stable tectonics, and a favorable chemical composition. Even minor deviations in these factors could render Earth sterile. Throughout history, life has survived asteroid impacts, supervolcanoes, climate shifts, and mass extinctions, yet survival is never guaranteed. The universe is indifferent, and life persists only because it has found a narrow niche within a chaotic, hostile environment. Even at the microscopic scale, danger is pervasive. Strangelets, hypothetical particles of exotic quark matter, could theoretically convert ordinary matter into more of themselves, triggering chain reactions across planets or stars. Exotic forms of matter, yet undiscovered, may hold latent potential to reshape or annihilate reality. Quantum fluctuations, invisible and silent, may propagate fundamental changes across the universe. In other words, danger is intrinsic. It exists, not only in stars, planets, or radiation, but in the very laws and particles that constitute reality itself. Yet, humanity endures. Despite the universe's indifference, life persists on a tiny rock orbiting a modest star in an ordinary galaxy. Every act of observation, every exploration, every thought is a defiance of forces that could annihilate existence in moments. Knowledge itself becomes a survival tool. We measure black holes, track asteroids, study gamma-ray bursts, and theorize about dark energy. Awareness allows us to navigate danger, yet limits remain. The universe conceals hazards that may never be fully understood. Survival is contingent on both knowledge and fortune. The universe does not seek to harm life, it is indifferent. Stars explode because physics dictates. Black holes consume because gravity compels. Gamma-ray bursts release energy because matter collapses. These processes have no intent, no morality, no favoritism. They simply are. Indifference, not malevolence, is what makes the cosmos most dangerous. Life exists not because the universe is hospitable, but because survival is improbable. Every conscious moment is a defiance of forces that could erase us entirely. Amidst this cosmic peril, there is also profound beauty. The universe is vast, intricate, and awe-inspiring. Life, fragile though it may be, emerges against staggering odds. Consciousness arises amidst cataclysmic forces. Stars illuminate the darkness, planets harbor complexity, and galaxies spiral in graceful, violent motion. Danger and beauty are inseparable. The perilous cosmos is also the stage upon which life's miracle unfolds. Awareness of danger heightens appreciation of existence. Survival becomes meaningful precisely because it is improbable, and yet the universe continues, indifferent and eternal. Stars ignite and fade, galaxies collide and merge, black holes devour, radiation sweeps through space, and time marches on. Every particle, every photon, every gravitational wave reminds us of the forces that could end existence in an instant. Life persists, a fleeting, improbable phenomenon in a cosmos unconcerned with its fate. Knowledge, courage, curiosity, and resilience become acts of defiance against an indifferent universe. Perhaps the most terrifying realization is that danger is omnipresent, absolute, and inevitable. Gamma-ray bursts, black holes, magnetars, dark energy, vacuum decay, and entropy all point to a universe where life is neither guaranteed nor protected. Yet humanity exists, observes, and explores, carving meaning from the precarious edge of survival. The greatest danger is not a single object or event, it is the universe itself, vast, indifferent, and relentless in its power to annihilate. And yet, against this backdrop of endless peril, wonder persists. Life contemplates stars, measures cosmic phenomena, and imagines realms beyond perception. Each act of observation, each scientific discovery, and each exploration is a defiance of the universe's indifference. Life, fragile and improbable, thrives for fleeting moments amidst infinite danger. Consciousness emerges in a cosmos that offers no guarantees, no protection, and no mercy. In this juxtaposition of peril and beauty lies the ultimate story, that survival, curiosity, and awareness are miracles in a universe defined by indifference and danger. The universe's dangers are myriad, explosive, subtle, visible, and hidden, from gamma-ray bursts that sterilize planets, to black holes that devour stars, to quantum fluctuations that could rewrite reality. From the patient erosion of time to the unpredictable wanderings of rogue celestial objects, danger is constant and unavoidable, yet life persists. Humanity exists, explores, and observes. Every conscious moment is a triumph against incomprehensible forces. Survival is fleeting, yet extraordinary, precisely because the universe is indifferent. In the end, the most dangerous thing in the universe may not be any star, planet, or phenomenon. It is the universe itself, infinite, indifferent, patient, and relentless. Every heartbeat, every breath, every thought exists in defiance of unimaginable forces. Yet in this peril lies wonder, beauty, and meaning. The universe is a vast theater of unimaginable forces, where creation and destruction dance in a relentless cycle. Every star that ignites, every planet that forms, and every galaxy that spirals is evidence of energy, matter, and motion operating on scales that challenge comprehension. And yet, within this grandeur, danger is omnipresent. It lurks not only in visible objects, but in invisible forces, in the very fabric of reality, waiting silently, patiently, to assert its indifferent power. Consider black holes once more, whose presence dominates the regions of space around them. Their gravity is absolute, warping space and time, bending light, and distorting reality. Stellar mass black holes consume entire stars, while supermassive black holes anchor galaxies, dictating the paths of billions of stars over eons. Crossing the event horizon of any black hole means instant and irrevocable destruction. Matter is stretched, compressed, and absorbed into the singularity, and even light, the fastest entity in the universe, cannot escape. Black holes are a stark reminder that the universe contains forces that operate beyond survival and comprehension, where existence itself is fragile and fleeting. But black holes are not the only cosmic predators. Neutron stars and magnetars carry their own lethal potential. Neutron stars, the remnants of massive supernova, contain mass so dense that a teaspoon weighs billions of tons on Earth. Many rotate at hundreds of revolutions per second, emitting focused beams of radiation. A pulsar beam sweeping across a planet could strip its atmosphere and incinerate life. Magnetars, with magnetic fields trillions of times stronger than Earth's, can twist atoms and distort molecules. A flare from a magnetar could obliterate a planet's atmosphere across thousands of kilometers, leaving nothing alive in its path. These celestial objects embody danger that is both extreme and invisible until it strikes. Gamma ray bursts silent, invisible assassins add, Yet another layer of peril. These narrow, high-energy beams travel across the cosmos at nearly the speed of light, capable of sterilizing planets from thousands of light-years away. They result from the collapse of massive stars or the collision of neutron stars. Entire civilizations could be wiped out in seconds by a burst they cannot see or anticipate. The universe's dangers are often impersonal, indifferent, and instantaneous, reminding us that survival is contingent on both awareness and luck. Then there is dark energy, the mysterious force accelerating the expansion of the universe. Its effect is subtle now, but inexorable. Over billions of years, it could trigger the Big Rip, a scenario where galaxies, stars, planets, and atoms are torn apart as space itself stretches beyond limits. Unlike a gamma ray burst or a black hole, dark energy operates on a scale so vast it is almost unimaginable. Its threat is not local or immediate, but absolute, pervasive, and universal. The fabric of reality itself may be vulnerable to forces we scarcely comprehend. Dark matter, though invisible and weakly interacting, is equally potent. It governs the structure of galaxies, influencing the motion of stars and the formation of cosmic clusters. Were its properties slightly different, galaxies could collapse or disperse, destabilizing countless star systems. Invisible forces like these remind us that the universe's deadliest threats are not always tangible. They may be hidden in the very scaffolding of existence, operating silently and invisibly, yet capable of shaping or ending life across entire galaxies. Time, relentless and impartial, is another formidable danger. Stars live for billions of years, but even they are mortal. Planets orbit within fragile habitable zones, yet their stability is never guaranteed. Earth itself has witnessed asteroid impacts, supervolcanic eruptions, and mass extinctions. Even if a planet avoids immediate cosmic catastrophes, it is still subject to the patient, unyielding erosion of time. The sun will exhaust its fuel, expand, and engulf the inner planets. Stars die, galaxies age, and the universe moves inexorably toward entropy. Time does not kill violently, but it ensures that nothing lasts forever. Rogue objects add unpredictability to this cosmic hazard landscape. Planets ejected from their systems drift silently through interstellar space, capable of destabilizing orbits and colliding with other worlds. Rogue black holes can wander into star systems, consuming stars or flinging planets into cold, empty voids. Even small celestial shifts can trigger catastrophic consequences. The universe's dangers are therefore multidimensional, operating across scales, distances, and energies beyond human perception. Survival is provisional, contingent, and precarious. Life itself is an act of defiance. Earth exists because an improbable set of conditions aligned perfectly. Distance from the sun, magnetic field protection, tectonic stability, and chemical composition. Even minor deviations could render our planet sterile. Life has survived asteroid impacts, climate shifts, and mass extinctions, proof of both resilience and fragility. Humanity's existence, perched on a fragile planet in an indifferent universe, is a fleeting triumph over forces that could annihilate us without warning. At microscopic scales, danger persists. Hypothetical strangelets, exotic quark matter, or other undiscovered particles could trigger chain reactions that convert ordinary matter into exotic matter, destroying planets or stars. Quantum fluctuations, vacuum decay, or other subtle phenomena might fundamentally rewrite reality, annihilating everything in their path. The universe's deadliest forces are often invisible, operating in ways beyond comprehension, reminding us that the cosmic threat landscape extends far beyond the tangible or visible. Despite all this, humanity endures. We observe stars, map cosmic rays, track near-Earth objects, and theorize about dark energy and quantum fluctuations. Knowledge allows us to anticipate some dangers, yet it is limited. The universe conceals hazards we may never understand. Survival is a combination of preparation, awareness, and, above all, luck. Every act of observation, exploration, or understanding is a defiance of forces that could erase existence in an instant. The universe's indifference is its most terrifying feature. Gamma bursts, black holes, magnetars, and dark energy do not discriminate. They do not target life, and they do not spare it. Survival is not a function of benevolence, but of chance. Every moment of consciousness, every act of creativity, every observation of the stars is a temporary triumph in a cosmos that does not guarantee continued existence. Yet, this very indifference gives rise to awe. Life exists, consciousness emerges, and knowledge grows in a universe filled with peril. Stars burn brightly, galaxies spiral gracefully, and planets harbor complexity and wonder. Danger and beauty are intertwined. The cosmos hazards give meaning to survival. Humanity's existence is remarkable precisely because it is improbable. Against a backdrop of cosmic destruction, even fleeting consciousness is extraordinary. The universe's dangers are manifold. Gamma ray bursts that sterilize planets, black holes that devour stars, magnetars with their immense magnetic fields, quantum fluctuations that could rewrite reality, and the relentless progression of time itself. Every element, particle, and force operates without concern for life, yet life persists. Humanity exists, observes, and contemplates the cosmos, carving meaning from the precarious balance between survival and annihilation. Perhaps the ultimate realization is this: the universe itself is the most dangerous entity. Infinite, indifferent, and relentless, it contains forces capable of erasing everything we know in an instant. And yet, life exists, consciousness emerges, and knowledge grows, all defying a cosmos that offers no protection, no mercy, and no guarantees. Survival, exploration, and understanding are miraculous precisely because the universe is so dangerous. In this perilous, indifferent cosmos, wonder persists. Life contemplates the stars, studies black holes, maps gamma ray bursts, and theorizes about dark matter and dark energy. Humanity persists on a fragile rock in a vast, hostile universe. Yet we observe, create, and understand. Every act of awareness is a triumph against forces that could annihilate us in seconds or eons. Danger is constant, yet life persists. Consciousness emerges amidst catastrophe. Knowledge grows amidst uncertainty. Survival is fleeting but extraordinary, the most dangerous thing in the universe. Then is not a single object, force, or event. It is the universe itself, infinite, indifferent, relentless, and unpredictable. Every star, every black hole, every gamma ray burst, and every quantum fluctuation is a reminder that life exists in defiance of unimaginable peril. Yet within this danger lies meaning, beauty, and wonder. Humanity endures, observes, and contemplates existence, drawing courage and understanding from a cosmos that could erase us at any moment. The universe is alive with peril and beauty alike. Stars flare, black holes consume, gamma ray bursts streak, Silently across galaxies, and time marches onward. Rogue planets drift, quantum fluctuations stir, and dark energy stretches the cosmos. Life persists against all odds, carving a fragile niche amidst chaos. Humanity, tiny and fleeting, endures, observes, and imagines. In the interplay of danger and survival, the miracle of consciousness emerges. Knowledge, curiosity, and courage are acts of defiance against forces that dwarf comprehension. Ultimately, the universe's most profound lesson is humility. Its dangers are omnipresent, absolute, and indifferent. Life exists despite these forces, and consciousness emerges against impossible odds. The universe is a realm of extremes, where unimaginable forces operate simultaneously and indifferently. Life, as fragile as it is, exists only because the cosmos allows a narrow window of conditions to persist. Yet these conditions are fleeting and precarious. Every star that shines, every planet that harbors life, every molecule that forms, is subject to forces that could, in an instant, undo existence. And within this precarious balance, danger is not merely present, it is fundamental. Consider the sheer scale of black holes, stellar mass black holes, remnants of massive stars, possess gravity so immense that no particle, not even light, can escape once it crosses the event horizon. Supermassive black holes, millions to billions of times the mass of our Sun, govern the motion of entire galaxies, shaping their structure and fate. Intermediate black holes, though still largely hypothetical, could exist in star clusters, silently influencing their surroundings. Their presence is invisible, yet undeniable. To encounter one unawares is to invite instant destruction. A rare type of neutron star push danger to extremes that defy imagination. Their magnetic fields, trillions of times stronger than Earth's, are capable of warping atoms and bending light itself. A magnetar flare could strip the atmosphere from a planet across thousands of kilometers, destroying all life in its path, even at distances considered safe for observation. The energy released could disrupt electronics, trigger geological activity, or alter chemical processes. Magnetars remind us that the universe's most potent dangers are not always frequent, but their power is absolute. Gamma ray bursts amplify the universe's lethal unpredictability. These bursts, resulting from the collapse of massive stars or the collision of neutron stars, release focused beams of energy equivalent to billions of suns. A planet directly in the path of such a burst would be sterilized almost instantly. These events are not only violent, but invisible and unpredictable. A civilization could thrive for eons, only to be extinguished in moments by a force originating thousands or millions of light years away. The cosmos does not care for life, it simply exists, indifferent and absolute. Dark energy, the driver of the universe's accelerated expansion, represents danger on an unimaginable scale. Over billions of years, it may lead to a scenario called the Big Rip, where galaxies, stars, planets, and even atoms are torn apart. Unlike visible threats, dark energy's danger is subtle, pervasive, and patient. Its effects unfold over eons, imperceptible in the short term but absolute in their ultimate reach. Dark energy reminds us that some cosmic dangers are not instantaneous but inescapable and universal. Dark matter, while invisible and weakly interacting, exerts a gravitational influence that shapes galaxies and governs the motion of stars. A slight alteration in its behavior could destabilize stellar systems, sending planets adrift or triggering catastrophic collisions. Invisible forces like dark matter and dark energy reveal that the universe's deadliest threats often operate silently, beyond direct observation, yet with the potential to affect life on scales beyond comprehension. Time, the silent predator, shapes existence with relentless impartiality. Stars burn, planets age, and galaxies evolve. Entropy ensures that order ultimately decays into chaos. Even if a civilization avoids sudden catastrophes, time guarantees eventual extinction. The sun will exhaust its fuel, expanding into a red giant and potentially consuming the inner planets. Stars die, galaxies drift, and the universe moves inexorably toward entropy. Time is not violent, but it is absolute, a force against which no life can ultimately prevail. Rogue celestial objects introduce chaos and unpredictability. Wandering planets, black holes, or stars may intrude into stable systems, destabilizing orbits and triggering destruction. Even minor gravitational disturbances can produce catastrophic consequences over time. The universe's dangers are multidimensional, operating across scales, energies, and distances that far exceed human comprehension. Survival depends on observation, luck, and the improbable alignment of conditions. Life itself is a fragile triumph against cosmic odds. Earth exists because countless factors aligned: its orbit within the habitable zone, a protective magnetic field, tectonic stability, and favorable chemical composition. Even slight deviations in these factors could render our planet sterile. Life has survived asteroid impacts, supervolcanoes, mass extinctions, and dramatic climate shifts. Humanity's existence is temporary and delicate, a brief window of consciousness, in a universe largely indifferent to survival. At the microscopic level, danger persists. Hypothetical strangelets, quark matter, or other exotic forms of matter could trigger chain reactions, capable of converting ordinary matter into a fundamentally different state. Quantum fluctuations and vacuum decay may propagate at light speed, altering the laws of physics and annihilating all matter in their path. The universe's deadliest threats are often invisible, operating in ways beyond human perception, yet capable of shaping existence on cosmic scales. Despite all these hazards, humanity survives. Knowledge becomes a shield and a sword. We track near-Earth objects, measure gamma-ray bursts, observe black holes, and theorize about dark matter and dark energy. Understanding the universe provides partial protection, yet it cannot eliminate the absolute indifference of cosmic forces. Survival is temporary, a defiance of overwhelming odds. Every act of discovery is a triumph against forces that could erase existence in an instant. The universe's indifference is its most terrifying aspect. Cosmic catastrophes do not discriminate. Black holes do not pause. Gamma-ray bursts do not judge. Time marches on without concern. Survival is not assured. Every conscious moment, every thought, every act of exploration is a temporary triumph against an uncaring cosmos. Life persists, not because the universe is hospitable, but because survival is improbable. Humanity exists, observes, and contemplates existence against all odds. Yet, in the midst of this peril, there is awe. Life exists, consciousness emerges, knowledge grows. Stars illuminate the darkness, galaxies spiral in violent beauty, and planets harbor complex ecosystems. Danger and beauty coexist. Survival is extraordinary precisely because it is improbable. Consciousness is a miracle against a backdrop of indifference. Humanity's brief existence is a testament to resilience and chance in a cosmos defined by Extremes. The dangers of the universe are manifold. Gamma-ray bursts that sterilize planets, black holes that consume stars, magnetars with their immense magnetic fields, quantum fluctuations that could rewrite reality, and the patient erosion of time itself. These forces operate without intent, yet they shape the fate of worlds, civilizations, and life itself. Every element, every particle, every cosmic event is a reminder of the precariousness of existence. Perhaps the ultimate realization is this: the universe itself is the most dangerous entity. Infinite, indifferent, and relentless, it contains forces capable of erasing everything in moments or over eons. And yet, life exists. Consciousness emerges, knowledge grows, humanity survives, observes, and reflects. Survival, exploration, and understanding are miracles precisely because the universe is indifferent and hazardous. Within this perilous cosmos lies beauty and meaning. Stars burn, galaxies collide, black holes devour, gamma-ray bursts streak across the void, and time marches inexorably forward. Life persists against incredible odds. Humanity, small and fragile, endures, observes, and imagines. Every act of awareness, every observation of the stars, is a triumph against forces that could annihilate us at any instant. Consciousness exists in defiance of unimaginable danger, drawing significance from survival in a hostile universe. Ultimately, the universe teaches humility. Its dangers are absolute, indifferent, and omnipresent. Life emerges and survives not because of cosmic benevolence, but because of extraordinary chance. Every heartbeat, every thought, every act of creation and observation is a miracle against a backdrop of unimaginable peril. Survival is fleeting, yet remarkable. Wonder exists because danger exists. Beauty emerges in a cosmos unconcerned with existence. Humanity's story, brief and fragile, is extraordinary precisely because it confronts a universe filled with peril. The universe is alive with danger and beauty alike. Stars flare, black holes consume, gamma-ray bursts sweep silently through space, and time marches onward. Rogue planets drift, quantum fluctuations stir, and dark energy stretches the cosmos. Life persists, carving a fragile niche amidst chaos. Humanity endures, observes, and contemplates. In the interplay of peril and survival, consciousness emerges. Knowledge, curiosity, and courage become acts of defiance against forces that dwarf comprehension. The most dangerous thing in the universe is not a single phenomenon, object, or event. It is the universe itself, infinite, indifferent, unpredictable, and relentless. Every star, black hole, gamma-ray, burst, and quantum fluctuation reminds us that existence is fragile and improbable. Yet life survives, consciousness emerges, knowledge grows. In this dangerous, indifferent cosmos lies wonder, meaning, and beauty. Humanity exists, observes, and reflects, drawing courage and understanding from a universe that could annihilate us at any moment. The universe is not merely vast. It is violent, indifferent, and relentless. Its dangers are subtle and overt, immediate and slow, visible and invisible. Every star that ignites, every planet that forms, and every particle in motion carries within it the potential for destruction. Life, as delicate as it is, persists against odds so improbable that the mere fact of consciousness is astonishing. To understand danger in the universe, one must consider both the scales of energy and time that far exceed human comprehension. Black holes exemplify this indifference. Stellar mass black holes, formed from the remnants of massive stars, possess gravity so overwhelming that nothing can escape once it passes the event horizon. Supermassive black holes, millions to billions of times more massive than the Sun, dominate entire galaxies, governing the movement of billions of stars. Intermediate black holes, still largely theoretical, may exist in star clusters, silently influencing their surroundings. These entities represent ultimate danger, invisible, absolute, and unavoidable if approached. To encounter a black hole is to confront annihilation itself. Magnetars, a type of neutron star, escalate cosmic peril to extremes beyond imagination. Their magnetic fields, trillions of times stronger than Earth's, can distort matter at the atomic level and warp light itself. A single flare could strip a planet's atmosphere from thousands of kilometers away, destroying all life instantly, even at a distance considered safe. The energy released could trigger geological activity, disrupt chemical processes, or alter atmospheres. Magnetars remind us that the universe's most potent threats need not be frequent. Their sheer power makes them catastrophic by default. Gamma-ray bursts amplify the universe's lethal unpredictability. These high-energy emissions, resulting from collapsing massive stars or neutron star mergers, release concentrated energy equivalent to billions of suns. Any planet caught directly in a burst would be sterilized almost instantly. Unlike black holes or magnetars, gamma-ray bursts are invisible and unpredictable. Civilizations can thrive for millennia, only to be obliterated in seconds by a force originating from millions of light-years away. Survival in such a universe is a combination of preparation, awareness, and incredible luck. Dark energy, the mysterious driver of cosmic expansion, represents danger on a scale incomprehensible to human minds. Over billions of years, it may lead to the Big Rip, where galaxies, stars, planets, and even atoms are torn apart as space itself stretches beyond recognition. Unlike visible cosmic threats, dark energy operates imperceptibly but universally. Its effects are gradual yet absolute, a reminder that some dangers unfold over eons, beyond the perception of any single civilization. Dark matter, though invisible and weakly interacting, dictates the structure of galaxies and governs stellar motion. Were its properties slightly different, galaxies could collapse or disperse, destabilizing countless star systems. The universe's deadliest threats are often invisible and operate beyond human perception. Yet their potential to affect life across entire galaxies is profound. Invisible forces shape the cosmos, silently asserting their influence with precision and inevitability. Time is another silent predator. Stars burn for billions of years, but even they are mortal. Planets drift in orbits that may not remain stable indefinitely. Entropy ensures that order eventually decays into chaos. Even if civilizations avoid sudden catastrophic events, time guarantees eventual extinction. The Sun, for example, will eventually exhaust its fuel, expand into a red giant, and engulf the inner planets. Time's danger is patient and absolute, operating over eons but ensuring that nothing persists forever. Rogue celestial objects introduce an element of unpredictability. Wandering planets, stars, or black holes may intrude into otherwise stable systems, destabilizing orbits, triggering collisions, or flinging planets into the void. Even minor gravitational shifts can have catastrophic consequences over time. The universe's hazards are multidimensional, operating across scales, distances, and energies that defy imagination. Survival is provisional, dependent on observation, understanding, and extraordinary chance. Life itself is a fragile triumph. Earth exists because an improbable alignment of conditions allows life to flourish. Its orbit within the habitable zone, a protective magnetic field, tectonic stability, and chemical composition. Even minor deviations could render our planet sterile. Life has endured asteroid impacts, supervolcanic eruptions, mass extinctions, and dramatic climate shifts. Humanity's existence is temporary and fragile, a brief, improbable flicker of consciousness in a cosmos largely indifferent to survival. Microscopic scales, danger persists. Hypothetical strangelets, quark matter, or exotic forms of matter could trigger chain reactions, converting ordinary matter into fundamentally different states. Quantum fluctuations or vacuum decay may propagate at light speed, altering the laws of physics and annihilating all matter. The universe's deadliest forces often operate invisibly, beyond direct observation, yet capable of shaping existence on cosmic scales. Despite all these hazards, humanity endures. Knowledge becomes both shield and sword. We track nearer objects, map gamma-ray bursts, observe black holes, and theorize about dark matter and dark energy. Understanding the universe allows some mitigation of danger, yet cannot eliminate the absolute indifference of cosmic forces. Survival is temporary defiance of overwhelming odds. Every act of discovery is a triumph against forces that could erase existence instantly. The universe's indifference is its most terrifying aspect. Cosmic catastrophes do not discriminate. Black holes consume without pause. Gamma-ray bursts strike without warning. Time marches on relentlessly. Survival is not guaranteed. Every conscious moment, every act of creation, every observation is a temporary triumph against an uncaring cosmos. Life persists not because the universe favors it, but because survival is improbable. Humanity exists, observes, and reflects in defiance of incomprehensible forces. Amid this peril lies profound beauty. Life exists, consciousness emerges, knowledge grows, stars illuminate the void, galaxies spiral in violent elegance, and planets harbor ecosystems of extraordinary complexity. Danger and beauty are intertwined. The cosmos hazards imbue existence with meaning. Survival is extraordinary precisely because it is improbable. Consciousness is miraculous against the backdrop of an indifferent, dangerous universe. Humanity's fleeting story is a testament to resilience and chance. The dangers of the universe are manifold: gamma-ray bursts that sterilize planets, black holes that consume stars, magnetars with their immense magnetic fields, quantum fluctuations capable of rewriting reality, and the slow, relentless erosion of time. These forces operate without intent, yet shape the fate of worlds, civilizations, and life itself. Every particle, every cosmic event, every fluctuation reminds us of the fragility of existence. The ultimate realization is chilling yet awe-inspiring. The universe itself is the most dangerous entity. Infinite, indifferent, and relentless, it contains forces capable of erasing everything we know in moments or eons. Yet life exists. Consciousness emerges. Knowledge grows. Humanity survives, observes, and contemplates. Survival, exploration, and understanding are miracles precisely because the universe is indifferent, hazardous, and unyielding. In this perilous cosmos, lies both beauty and meaning. Stars burn, galaxies collide, black holes devour, gamma ray bursts streak across the void, and time progresses inexorably. Life persists against incredible odds. Humanity, small and fleeting, endures, observes, and imagines. Every act of awareness, every observation of the stars, is a triumph against forces that could annihilate us instantly. Consciousness emerges amidst catastrophe, drawing significance from survival in a hostile universe. Ultimately, the universe teaches humility. Its dangers are absolute, indifferent, and omnipresent. Life exists not because of cosmic benevolence, but through extraordinary chance. Every heartbeat, thought, and observation is a miracle in a backdrop of unimaginable peril. Survival is fleeting yet remarkable. Wonder exists because danger exists. Beauty emerges in a cosmos unconcerned with life. Humanity's story, brief and fragile, is extraordinary precisely because it confronts a universe filled with peril. The universe is alive with danger and beauty alike. Stars flare, black holes consume, gamma ray bursts streak silently through space, and time marches onward. Rogue planets drift, quantum fluctuations stir, and dark energy stretches the cosmos. Life persists, carving a fragile niche amidst chaos. Humanity endures, observes, and contemplates. In the interplay of peril and survival, consciousness emerges. Knowledge, curiosity, and courage are acts of defiance against forces that dwarf comprehension. The most dangerous thing in the universe is not a single phenomenon, object, or event. It is the universe itself, infinite, indifferent, unpredictable, and relentless. Every star, black hole, gamma ray burst, and quantum fluctuation reminds us that existence is fragile and improbable. Yet life survives, consciousness emerges, knowledge grows. In this dangerous, indifferent cosmos lies wonder, meaning, and beauty. Humanity exists, observes, and reflects, drawing courage and understanding from a universe that could annihilate us at any moment. The universe is not simply a backdrop for life, it is a relentless arena of creation and annihilation, a theater of forces so vast and powerful that the survival of even the smallest life forms becomes miraculous. Stars ignite and burn for billions of years. Planets form and orbit, yet each particle, each photon, and each gravitational wave carries with it potential for destruction. To live in such a cosmos is to exist on a razor's edge, where stability is temporary, and the unexpected can obliterate existence in a moment. Black holes remain the ultimate manifestation of danger. Stellar mass black holes, born from the collapse of massive stars, possess gravitational forces so intense that nothing can escape once it crosses the event horizon. Supermassive black holes, anchoring the centers of galaxies, influence the movement of billions of stars. Intermediate black holes, though still largely hypothetical, may lurk unseen in star clusters, silently altering the paths of nearby celestial bodies. Approaching a black hole unknowingly is an encounter with absolute annihilation. Matter is stretched, compressed, and absorbed, leaving no trace of its prior existence. Magnetars elevate cosmic peril to extremes that strain comprehension. Their magnetic fields, trillions of times stronger than Earth's, distort matter at the atomic level, twist molecules, and warp light itself. A single magnetar flare could obliterate a planet's atmosphere across thousands of kilometers, annihilating life instantly. Even at considerable distances, the energy released could trigger seismic activity, alter chemical processes, or disrupt electronic systems. Rare yet immensely powerful. Magnetars exemplify dangers that need not be frequent to be catastrophic. Gamma ray bursts. Cosmic assassins, moving at near light speed, amplify the universe's unpredictability. These high-energy emissions, originating from collapsing massive stars or colliding neutron stars, can sterilize entire planets in seconds. Unlike black holes or magnetars, gamma-ray bursts are invisible until it is too late. Civilizations can exist for eons, only to be extinguished in an instant by a force originating thousands or millions of light-years away. Survival in such a cosmos requires not just awareness, but extraordinary luck. Dark energy represents a more subtle, yet equally terrifying, cosmic danger. Its effect on the universe is imperceptible in the short term, but absolute over billions of years. By driving the accelerated expansion of space, dark energy may ultimately lead to the Big Ripper scenario, where galaxies, stars, planets, and even atoms are torn apart as space itself stretches beyond recognition. Unlike gamma-ray bursts or black holes, dark energy is patient, indifferent, and all-encompassing. It is a threat that no civilization can escape, operating on a scale beyond comprehension. Dark matter, invisible yet omnipresent, governs the architecture of galaxies. Its gravitational influence dictates the orbits of stars and the stability of planetary systems. Were its properties slightly different, galaxies could collapse or disperse, destabilizing countless star systems. The universe's deadliest forces are often invisible, operating silently and imperceptibly, yet their consequences are vast. Even the most vigilant observers cannot see or touch these forces, yet they shape the fate of stars, planets, and life itself. Time itself is an inexorable predator. Stars live and die, planets orbit precariously, and galaxies evolve. Entropy ensures that order eventually decays into chaos. Even if sudden catastrophes are avoided, the patient passage of time guarantees eventual extinction. The sun will exhaust its fuel, expand into a red giant, and consume the inner planets. Stars burn out, galaxies drift, and entropy marches forward. Time is not violent, but absolute. It ensures that nothing lasts forever, rendering even the most resilient life forms temporary. Rogue celestial objects introduce chaos and unpredictability. Wandering planets, stars, or black holes may intrude into stable systems, destabilizing orbits and triggering collisions. Even minor gravitational shifts can lead to catastrophic consequences over time. The universe's hazards operate across dimensions, scales, and energies far beyond human comprehension. Survival is provisional, reliant on observation, preparation, and the improbable alignment of conditions. Life exists despite, not because of, cosmic stability. Life itself is a delicate triumph. Earth exists because countless factors align. Orbit within the habitable zone, protective magnetic field, tectonic stability, and chemical composition. Even slight deviations could render the planet sterile. Life has endured asteroid impacts, supervolcanic eruptions, climate shifts, and mass extinctions. Humanity's existence is temporary, a brief flicker of consciousness in an indifferent universe. Our survival is a testament to resilience and improbable chance. At microscopic scales, danger persists. Strangelets, quark matter, or hypothetical exotic particles could trigger chain reactions converting ordinary matter into exotic forms. Quantum fluctuations and vacuum decay could propagate at light speed, rewriting reality and annihilating all matter. The universe's deadliest threats often operate invisibly, yet they can reshape existence across cosmic scales. Even our most secure understanding of reality cannot fully predict these hazards. Despite these dangers, humanity survives. Knowledge is a shield and a tool. We track near-Earth objects, measure gamma-ray bursts, observe black holes, and theorize about dark energy and dark matter. Understanding mitigates some risk, but it cannot eliminate the indifference of the cosmos. Survival is temporary, a defiance of forces that could obliterate existence instantly. Every act of discovery, every exploration, is a triumph against overwhelming odds. The universe's indifference is its most terrifying feature. Cosmic catastrophes do not discriminate. Black holes consume relentlessly. Gamma-ray bursts strike without warning. Time continues unabated. Survival is not guaranteed. Every conscious moment, every thought, every act of creation is a fleeting victory against an uncaring cosmos. Life persists not because the universe favors it, but because survival is improbable. Humanity observes, reflects, and endures despite forces beyond comprehension. Yet within this peril exists awe. Life persists. Consciousness emerges. Knowledge grows. Stars illuminate darkness. Galaxies spiral in violent beauty, and planets harbor complex ecosystems. Danger and beauty are inseparable. Survival is remarkable precisely because it is improbable. Consciousness is miraculous in an indifferent universe. Humanity's story, brief and fragile, is a testament to resilience and chance. The universe's hazards are manifold. Gamma-ray bursts, black holes, magnetars, quantum fluctuations, and the patient passage of time. These forces shape the fate of worlds and civilizations without intent. Every cosmic event is a reminder of fragility and impermanence. Survival is contingent on awareness, preparation, and luck. Humanity exists, observes, and reflects, creating meaning amidst chaos. Ultimately, the most dangerous entity is the universe itself, infinite, indifferent, and relentless. Its forces could annihilate everything in moments or eons. Yet life emerges, consciousness arises, knowledge grows, humanity survives, observes, and contemplates. Survival, exploration, and understanding are miracles against a cosmos that offers no protection. In this perilous reality lies beauty and meaning. Stars burn, galaxies collide, black holes consume, gamma-ray bursts streak across the void, and time marches forward. Life endures against unimaginable odds. Humanity, small and fleeting, persists, observes, and imagines. Every act of awareness is a triumph against forces that could erase existence. Consciousness emerges amidst catastrophe, and knowledge flourishes. Despite danger, the universe teaches humility. Its dangers are omnipresent and absolute. Life survives, not due to benevolence, but due to improbable alignment of conditions and chance. Every heartbeat, thought, and observation is a miracle. Survival is fleeting, yet extraordinary. Wonder exists because danger exists. Beauty arises in a universe unconcerned with existence. Humanity's story is remarkable precisely because it confronts a universe filled with peril. The universe pulses with danger and beauty alike. Stars flare, black holes consume, gamma-ray bursts streak silently through space, and time moves relentlessly. Rogue planets drift, quantum fluctuations stir, and dark energy expands the cosmos. Life persists, carving a fragile niche amidst chaos. Humanity endures, observes, and contemplates. Consciousness emerges in the interplay of peril and survival. Knowledge, curiosity, and courage are acts of defiance against incomprehensible forces. The most dangerous thing in the universe is not a single event, object, or phenomenon. It is the universe itself, infinite, indifferent, unpredictable, and relentless. Every star, black hole, gamma ray burst, and quantum fluctuation reminds us that existence is fragile and improbable. Yet life persists, consciousness emerges, knowledge grows, humanity exists, observes, and reflects, drawing meaning and courage from a cosmos that could annihilate us at any moment. The universe is an arena of extremes, a stage where creation and annihilation exist in perpetual balance. Stars ignite and die, planets form and disintegrate, and galaxies collide in a cosmic dance of unimaginable force. Each particle, photon, and gravitational wave carries with it the potential for destruction. Life exists only because it navigates these forces with improbable precision. To contemplate the universe is to confront both awe and terror, the beauty of existence entwined with the inevitability of annihilation. Black holes remain among the most potent symbols of cosmic danger. Stellar mass black holes, remnants of massive stars, possess gravitational fields so intense that nothing can escape once it crosses the event horizon. Supermassive black holes dominate the centers of galaxies, influencing the orbits of billions of stars. Intermediate black holes, though largely theoretical, may lurk unseen in globular clusters, silently affecting nearby celestial bodies. Encountering a black hole unknowingly is a confrontation with absolute destruction. Matter is stretched, compressed, and absorbed into singularity, leaving no trace of its prior existence. Magnetars represent danger on a scale that defies imagination. These neutron stars possess magnetic fields trillions of times stronger than Earth's, distorting matter at the atomic level and warping light itself. A single magnetar flare could strip a planet's atmosphere across thousands of kilometers, instantly annihilating life. Even at great distances, the energy released could trigger seismic activity, alter chemical reactions, or disrupt electronic systems. Rare but overwhelmingly powerful, magnetars remind us that the universe's deadliest threats need not be frequent, they need only exist. Gamma-ray bursts amplify the universe's unpredictability and lethality, resulting from the collapse of massive stars or neutron star collisions. These bursts release energy equivalent to billions of suns in a concentrated beam. Any planet caught in the path would be sterilized almost instantly. Unlike black holes or magnetars, gamma-ray bursts are invisible until their effects strike. Civilizations could flourish for millennia, only to be extinguished in seconds by a force from millions of light-years away. Survival in such a universe demands extraordinary chance. Dark energy, though subtle, represents danger on a scale beyond human comprehension, driving the accelerated expansion of the universe. It may ultimately lead to the Big Ripper scenario where galaxies, stars, planets, and even atoms are torn apart as space stretches infinitely. Unlike instantaneous disasters, dark energy operates gradually, inexorably, and universally. No civilization can escape its ultimate consequences. Its presence reminds us that some cosmic hazards unfold over eons, imperceptible yet absolute. Dark matter, invisible yet omnipresent, dictates the architecture of galaxies. Its gravitational influence determines the orbits of stars and the stability of planetary systems. Slight deviations in its behavior could destabilize entire galaxies, sending planets adrift or triggering catastrophic collisions. The universe's deadliest forces are often invisible, operating silently and imperceptibly, yet their impact is monumental. The invisible scaffolding of reality itself is fraught with peril. Time is an inexorable predator. Stars burn, planets orbit precariously, and galaxies evolve. Entropy ensures that order decays into chaos. Even absent catastrophic events, the relentless march of time guarantees extinction. The sun will eventually exhaust its fuel, expanding into a red giant and engulfing the inner planets. Stars fade, galaxies drift apart, and entropy governs the cosmos. Time's danger is patient but absolute, a silent force against which no life can ultimately prevail. Rogue, celestial objects introduce unpredictability into this delicate balance. Wandering planets, stars, or black holes may intrude into stable systems, destabilizing orbits and triggering collisions. Even minor gravitational shifts can produce catastrophic consequences over time. The universe's hazards operate across dimensions, scales, and energies far beyond human comprehension. Survival is provisional, reliant on observation, preparation, and extraordinary chance. Life exists despite, not because of, cosmic stability. Life itself is a fragile triumph. Earth exists because countless factors align, orbit within the habitable zone. Protective magnetic field, tectonic stability, and chemical composition. Even slight deviations could render the planet sterile. Life has endured asteroid impacts, supervolcanic eruptions, climate shifts, and mass extinctions. Humanity's existence is temporary, a fleeting spark of consciousness in an indifferent universe. Survival is a testament to resilience and improbable chance. At microscopic scales, danger persists. Strangelets, quark matter, and exotic hypothetical particles could trigger chain reactions converting ordinary matter into fundamentally different states. Quantum fluctuations and vacuum decay could propagate at light speed, annihilating matter and rewriting the fabric of reality. The universe's deadliest forces are often invisible, operating beyond direct observation, yet capable of shaping existence across cosmic scales. Even the most secure understanding of reality cannot fully account for these hazards. Despite these dangers, humanity persists. Knowledge becomes both shield and tool. We track near-Earth objects, measure gamma bursts, observe black holes, and theorize about dark energy and dark matter. Understanding mitigates risk, but cannot eliminate the indifference of the cosmos. Survival is temporary, a defiance against forces that could obliterate existence instantly. Every act of discovery, exploration, and comprehension is a triumph. Against overwhelming odds, the universe's indifference is its most terrifying aspect. Catastrophes do not discriminate. Black holes consume relentlessly. Gamma-ray bursts strike without warning. Time continues unabated. Survival is uncertain. Every conscious moment, every thought, every act of creation is a fleeting victory against an uncaring cosmos. Life exists not because the universe favors it, but because survival is improbable. Humanity exists, observes, and reflects in defiance of incomprehensible forces. Yet within this peril lies awe. Life persists. Consciousness emerges. Knowledge grows. Stars illuminate darkness. Galaxies spiral in violent elegance, and planets harbor complex ecosystems. Danger and beauty coexist. Survival is extraordinary precisely because it is improbable. Consciousness is miraculous in an indifferent universe. Humanity's brief story is a testament to resilience and chance. The universe's hazards are manifold: gamma-ray bursts, black holes, magnetars, quantum fluctuations, and the relentless passage of time. These forces shape the fate of worlds and civilizations without intent. Every cosmic event is a reminder of fragility and impermanence. Survival relies on awareness, preparation, and luck. Humanity exists, observes, and reflects, creating meaning amidst chaos. Ultimately, the most dangerous entity is the universe itself, infinite, indifferent, and relentless. Its forces could annihilate everything in moments or eons. Yet life emerges, consciousness arises, knowledge grows. Humanity survives, observes, and contemplates. Survival, exploration, and understanding are miracles against a cosmos that offers no protection. In this perilous cosmos lies both beauty and meaning. Stars burn, galaxies collide, black holes consume, gamma-ray bursts streak across the void, and time marches forward. Life endures against unimaginable odds. Humanity, small and fleeting, persists, observes, and imagines. Every act of awareness is a triumph against forces that could erase existence. Consciousness emerges amidst catastrophe, and knowledge flourishes despite danger. The universe teaches humility. Its dangers are omnipresent and absolute. Life survives not due to benevolence, but because of improbable alignment of conditions and chance. Every heartbeat, thought, and observation is a miracle. Survival is fleeting yet extraordinary. Wonder exists because danger exists. Beauty arises in a universe unconcerned with existence. Humanity's story is remarkable precisely because it confronts a universe filled with peril. The universe pulses with danger and beauty alike. Stars flare, black holes consume, gamma-ray bursts streak silently through space, and time moves relentlessly. Rogue planets drift, quantum fluctuations stir, and dark energy expands the cosmos. Life persists, carving a fragile niche amidst chaos. Humanity endures, observes, and contemplates. Consciousness emerges in the interplay of peril and survival. Knowledge, curiosity, and courage are acts of defiance against incomprehensible forces. The most dangerous thing in the universe is not a single event, object, or phenomenon. It is the universe itself, infinite, indifferent, unpredictable, and relentless. Every star, black hole, gamma-ray burst, and quantum fluctuation reminds us that existence is fragile and improbable. Yet life persists, consciousness emerges, knowledge grows. Humanity exists, observes, and reflects, drawing meaning and courage from a cosmos that could annihilate us at any moment. The universe is not just vast, it is a realm of extremes, an expanse where creation and destruction occur simultaneously, often without warning. Stars ignite, live, and die, releasing energy that can shape or annihilate nearby worlds. Galaxies collide, black holes consume, and gamma-ray bursts erupt with energies beyond comprehension. Every particle, every photon, every gravitational wave carries within it the potential for destruction. Life exists as a fragile, improbable triumph against these overwhelming forces. To exist in such a universe is to navigate constant peril, where stability is temporary and the unexpected can obliterate existence in an instant. Black holes epitomize cosmic danger. Stellar mass, black holes, remnants of massive stars, have gravity, so intense that nothing, no particle, no light can escape once it passes the event horizon. Supermassive black holes, millions or billions of times the mass of our Sun, dominate galactic centers, influencing the motion of billions of stars. Intermediate black holes, still largely theoretical, may lurk undetected in star clusters, subtly bending the paths of nearby celestial objects. Encountering a black hole unknowingly means instant annihilation. Matter is stretched, compressed, and absorbed into singularity, leaving no trace. Magnetars take danger to an unimaginable level. These neutron stars possess magnetic fields, trillions of times stronger than Earth's, capable of distorting matter at the atomic scale and warping light itself. A single flare could strip a planet's atmosphere across thousands of kilometers, instantly annihilating life. Even at distances deemed safe, their energy can trigger seismic activity, disrupt chemical processes, and alter planetary atmospheres. Rare but immensely powerful, magnetars illustrate that some dangers need not be frequent to be. Catastrophic gamma ray bursts GRBs amplify the universe's unpredictability. They occur when massive stars collapse or neutron stars collide, releasing concentrated energy equivalent to billions of suns. Any planet in the direct path would be sterilized in seconds. Unlike black holes or magnetars, GRBs are invisible until their destructive effects reach a target. Civilizations may thrive for millennia, only to be extinguished in moments by a force originating millions of light years away. Survival in such a universe requires not just awareness, but extraordinary luck. Dark energy represents a subtle, patient danger, responsible for the accelerated expansion of the universe. It may eventually lead to the Big Rip, a scenario in which galaxies, stars, planets, and even atoms are torn apart as space stretches infinitely. Unlike sudden cosmic disasters, dark energy operates gradually, invisibly, and universally. No civilization can evade its ultimate consequences. It is a threat that unfolds over eons, beyond the perception of any single observer, yet absolute in its scope. Dark matter, though invisible, shapes the cosmos. Its gravitational influence governs the orbits of stars and the stability of planetary systems. Were its properties slightly different, galaxies could collapse or disperse, destabilizing entire star systems. Invisible forces, like dark matter, reveal that the deadliest threats often operate silently, beyond human perception, yet have the power to reshape entire galaxies. Even without immediate visibility, these forces dictate the fates of stars, planets, and life itself. Time is an inexorable predator. Stars burn, planets orbit precariously, and galaxies evolve. Entropy ensures that all order decays into chaos. Even if sudden catastrophic events are avoided, time guarantees eventual extinction. The sun will exhaust its fuel, expand into a red giant, and likely consume the inner planets. Stars fade, galaxies drift apart, and entropy reigns. Time's danger is patient and absolute, a silent force against which no life can ultimately prevail. Rogue celestial objects introduce chaos and unpredictability. Wandering planets, stars, or black holes may intrude into otherwise stable systems, disrupting orbits and triggering collisions. Even minor gravitational shifts can produce catastrophic consequences over time. The universe's hazards operate across dimensions, scales, and energies far beyond human comprehension. Survival is provisional, dependent on observation, preparation, and improbable alignment of conditions. Life persists, despite not because of cosmic stability. Life itself is a fragile triumph. Earth exists because countless factors align, orbit within the habitable zone, a protective magnetic field, tectonic stability, and chemical composition. Even slight deviations could render the planet sterile. Life has survived asteroid impacts, supervolcanic eruptions, climate shifts, and mass extinctions. Humanity's existence is a fleeting spark of consciousness in an indifferent universe. Our survival is a testament to resilience and improbable chance. At microscopic scales, danger persists. Strangelets, quark, matter, or exotic hypothetical particles could trigger chain reactions, converting ordinary matter into fundamentally different states. Quantum fluctuations and vacuum decay could propagate at light speed, annihilating matter and rewriting the fabric of reality. The universe's deadliest threats often operate invisibly, beyond direct observation, yet capable of shaping existence across cosmic scales. Even the most secure understanding of reality cannot fully predict these hazards. Despite these dangers, humanity persists. Knowledge becomes both shield and tool. We track near-Earth objects, measure gamma-ray bursts, observe black holes, and theorize about dark energy and dark matter. Understanding mitigates risk, but cannot eliminate the indifference of the cosmos. Survival is temporary, a defiance of forces that could obliterate existence instantly. Every act of discovery, exploration, and comprehension is a triumph against overwhelming odds. The universe's indifference is its most terrifying aspect. Catastrophes do not discriminate. Black holes consume relentlessly. Gamma-ray bursts strike without warning. Time marches on. Survival is uncertain. Every conscious moment, every thought, every act of creation is a fleeting victory against an uncaring cosmos. Life exists not because the universe favors it, but because survival is improbable. Humanity observes, reflects, and endures despite forces beyond comprehension. Yet within this peril exists awe. Life persists. Consciousness emerges. Knowledge grows. Stars illuminate darkness. Galaxies spiral in violent elegance, and planets harbor complex ecosystems. Danger and beauty coexist. Survival is extraordinary precisely because it is improbable. Consciousness is miraculous in an indifferent universe. Humanity's brief story is a testament to resilience and chance. The universe's hazards are manifold. Gamma-ray bursts, black holes, magnetars, quantum fluctuations, and the relentless passage of time. These forces shape the fate of worlds and civilizations without intent. Every cosmic event is a reminder of fragility and impermanence. Survival relies on awareness, preparation, and luck. Humanity exists, observes, and reflects, creating meaning amidst chaos. Ultimately, the most dangerous entity is the universe itself, infinite, indifferent, and relentless. Its forces could annihilate everything in moments or eons. Yet life emerges, consciousness arises, knowledge grows, humanity survives, observes, and contemplates. Survival, exploration, and understanding are miracles against a cosmos that offers no protection. In this perilous cosmos lies both beauty and meaning. Stars burn, galaxies collide, black holes consume, gamma-ray bursts streak across the void, and time marches forward. Life endures against unimaginable odds. Humanity, small and fleeting, persists, observes, and imagines. Every act of awareness is a triumph against forces that could erase existence. Consciousness emerges amidst catastrophe, and knowledge flourishes despite danger. The universe teaches humility. Its dangers are omnipresent and absolute. Life survives not due to benevolence, but because of improbable alignment of conditions and chance. Every heartbeat, thought, and observation is a miracle. Survival is fleeting yet extraordinary. Wonder exists because danger exists. Beauty arises in a universe unconcerned with existence. Humanity's story is remarkable precisely because it confronts a universe filled with peril. The universe pulses with danger and beauty alike. Stars flare, black holes consume, gamma ray bursts streak silently through space, and time moves relentlessly. Rogue planets drift, quantum fluctuations stir, and dark energy expands the cosmos. Life persists, carving a fragile niche amidst chaos. Humanity endures, observes, and contemplates. Consciousness emerges in the interplay of peril and survival. Knowledge, curiosity, and courage are acts of defiance against incomprehensible forces. The most dangerous thing in the universe is not a single event, object, or phenomenon. It is the universe itself, infinite, indifferent, unpredictable, and relentless. Every star, black hole, gamma ray, burst, and quantum fluctuation reminds us that existence is fragile and improbable. Yet life persists, consciousness emerges, knowledge grows. Humanity exists, observes, and reflects, drawing meaning and courage from a cosmos that could annihilate us at any moment. The universe, in all its vastness, is both breathtakingly beautiful and unimaginably dangerous. Its forces operate across scales and energies that defy human comprehension, shaping the fate of stars, planets, and life itself. From the smallest quantum fluctuation to the titanic pull of supermassive black holes, the cosmos is a web of power and unpredictability. Every existence, every conscious moment, is a fleeting triumph against these immense and indifferent forces. Black holes remain the ultimate arbiters of cosmic destruction. Stellar remnants, compressed into singularities, exert gravitational forces so intense that not even light can escape. Supermassive black holes dominate the centers of galaxies, bending the motion of billions of stars, while intermediate black holes, often hidden, subtly reshape star clusters. Encountering one unknowingly is a confrontation with absolute annihilation. Matter is stretched, compressed, and absorbed, vanishing into the singularity without trace. Magnetars represent the universe's invisible fury. Their magnetic fields, trillions of times stronger than Earth's, can warp matter at the atomic level. A single flare could strip away a planet's atmosphere, erasing all life across thousands of kilometers. Even distant magnetars pose threats. Seismic activity, chemical disturbances, and radiation floods can ripple through nearby planetary systems. Rare yet catastrophic, these cosmic phenomena reveal that power is not measured by frequency but by potential. Gamma ray bursts amplify unpredictability to the extreme. Born from collapsing massive stars or colliding neutron stars, these bursts release energy equivalent to billions of suns in a concentrated beam. Planets caught in their path would be sterilized instantly. Unlike black holes or magnetars, GRBs are invisible until destruction occurs. Civilizations could flourish for millennia, only to be extinguished in seconds. Survival is a precarious combination of observation, preparation, and unimaginable luck. Dark energy is a quiet but patient menace. By driving the accelerated expansion of the universe, it may eventually cause the Big Rip, tearing galaxies, stars, planets, and even atoms apart. Unlike sudden disasters, Dark energy operates gradually and invisibly, yet its eventual consequences are absolute. No intelligence can escape its effects. Some dangers, though imperceptible over human lifetimes, unfold with certainty across cosmic epochs. Dark matter, though unseen, dictates the universe's architecture. It stabilizes galaxies, influences star orbits, and governs the formation of cosmic structures. Slight alterations in its properties could destabilize entire galaxies, sending planets adrift and triggering catastrophic collisions. Invisible forces often pose the most profound dangers, operating silently, imperceptibly, yet reshaping the cosmos at every level. Time itself is a relentless predator. Stars burn, planets orbit precariously, and galaxies evolve. Entropy ensures that all order decays into chaos. Even without sudden cataclysms, the passage of time guarantees eventual extinction. The sun will exhaust its fuel, expand into a red giant, and engulf the inner planets. Stars fade, galaxies drift, and the universe continues indifferent to survival. Time is patient, absolute, and unstoppably a force against which no life can prevail indefinitely. Rogue, celestial objects introduce chaos and unpredictability. Wandering planets, stars, or black holes can intrude into stable systems, destabilizing orbits and triggering collisions. Even minor gravitational shifts can have catastrophic outcomes over millions of years. The universe's dangers operate across scales and energies beyond human comprehension. Life persists not because of cosmic stability, but in spite of it, navigating a maze of probabilities that are rarely in its favor. Life is a delicate triumph. Earth exists because countless factors align: orbit within the habitable zone, protective magnetic field, tectonic stability, and chemical composition. Even slight deviations could render the planet sterile. Life has survived asteroid impacts, supervolcanic eruptions, climate shifts, and mass extinctions. Humanity's existence is a brief spark of consciousness in a universe largely indifferent to survival. Our presence is improbable, extraordinary, and temporary. At the smallest scales, danger persists. Strangelets, quark matter, or hypothetical exotic particles could trigger chain reactions, converting ordinary matter into exotic forms. Quantum fluctuations and vacuum decay may propagate at light speed, annihilating everything. Some of the universe's deadliest forces are invisible, operating beyond direct observation, yet capable of reshaping existence across cosmic scales. Even the most secure understanding of reality cannot fully account for these hazards. Despite these threats, humanity endures. Knowledge is both shield and tool. We track near-Earth objects, measure gamma-ray bursts, observe black holes, and theorize about dark energy and dark matter. Understanding mitigates some risk, but cannot alter the indifference of the cosmos. Survival is provisional, a defiance against forces that could erase existence instantly. Every act of discovery, exploration, and reflection is a triumph against overwhelming odds. The universe's indifference is its most terrifying aspect. Catastrophes do not discriminate. Black holes consume relentlessly, gamma-ray bursts strike without warning, and time marches on unyielding. Survival is uncertain. Every conscious moment, every thought, every act of creation is a fleeting victory against an uncaring cosmos. Life persists, not because of cosmic benevolence, but because survival is improbable. Humanity exists, observes, and reflects, defying forces beyond comprehension. Yet within this peril lies awe. Life endures, consciousness emerges, knowledge grows, stars illuminate darkness, galaxies spiral in violent elegance, and planets harbor complex ecosystems. Danger and beauty coexist. Survival is extraordinary precisely because it is improbable. Consciousness is miraculous in an indifferent universe. Humanity's story, brief and fragile, is a testament to resilience and chance. The universe's hazards are manifold: gamma-ray bursts, black holes, magnetars, quantum fluctuations, and the inexorable passage of time. These forces shape the fate of worlds and civilizations without intent. Every cosmic event is a reminder of fragility and impermanence. Survival relies on awareness, preparation, and improbable alignment of conditions. Humanity exists, observes, and reflects, creating meaning amidst chaos. Ultimately, the most dangerous entity is the universe itself, infinite, indifferent, and relentless. Its forces could annihilate everything in moments or eons. Yet life emerges, consciousness arises, knowledge grows. Humanity survives, observes, and contemplates. Survival, exploration, and understanding are miracles against a cosmos that offers no protection. In this perilous cosmos lies both beauty and meaning. Stars burn, galaxies collide, black holes consume, gamma-ray bursts streak across the void, and time marches forward. Life endures against unimaginable odds. Humanity, small and fleeting, persists, observes, and imagines. Every act of awareness is a triumph against forces that could erase existence. Consciousness emerges amidst catastrophe, and knowledge flourishes. Despite danger, the universe teaches humility. Its dangers are omnipresent and absolute. Life survives not due to benevolence, but because of improbable alignment of conditions and chance. Every heartbeat, thought, and observation is a miracle. Survival is fleeting yet extraordinary. Wonder exists because danger exists. Beauty arises in a universe unconcerned with existence. Humanity's story is remarkable precisely because it confronts a universe filled with peril. The cosmos stretches beyond comprehension, an infinite tapestry of creation and destruction. Every galaxy, every star, every particle plays its role in the grand drama of existence. The universe is at once majestic and merciless, filled with forces that can create life and obliterate it in a heartbeat. From the violent deaths of stars to the silent pull of dark matter, danger is omnipresent. Every moment of life, every flicker of consciousness, is a triumph against forces that could erase existence without hesitation. Black holes dominate as the universe's ultimate predators. Stellar remnants, crushed into singularities, warp space, and time so profoundly that nothing can escape their grasp. Supermassive black holes anchor the hearts of galaxies, influencing the motion of countless stars, while intermediate black holes, though elusive, shift star clusters imperceptibly. Encountering one is an encounter with finality. Matter is stretched, compressed, and consumed into oblivion, disappearing into the singularity with no trace of its former existence. Magnetars, with their staggering magnetic fields, demonstrate the universe's hidden fury. Their magnetism can distort atoms, warp molecules, and disrupt light itself. A single flare could strip an entire planet of its atmosphere, annihilating life across vast distances. Even from afar, their energy can ripple through space, triggering chemical reactions, seismic disturbances, and radiation floods. Rare but devastating, magnetars embody danger that requires no frequency to be catastrophic. Existence itself is enough. Gamma bursts GRBs magnify the universe's unpredictability, arising from collapsing massive stars or neutron star collisions. GRBs release energy equivalent to billions of suns, concentrated into narrow beams. Planets caught in their path are sterilized in an instant. Unlike black holes or magnetars, GRBs are invisible until their catastrophic effects are realized. Entire civilizations could flourish for millennia, only to vanish in seconds. Survival in such a cosmos is a delicate balance of observation, preparation, and extraordinary fortune. Dark energy, subtle yet omnipresent, drives the universe's accelerated expansion. Over billions of years, it may lead to the Big Rip, where galaxies, stars, planets, and even atoms are torn apart as space stretches infinitely. Unlike sudden cosmic catastrophes, dark energy operates patiently and invisibly, yet its consequences are absolute. No civilization can evade its ultimate outcome. Some of the universe's deadliest forces unfold slowly, imperceptibly, yet inevitably. Dark matter, though unseen, shapes the very architecture of the cosmos. It stabilizes galaxies, guides star orbits, and dictates the formation of cosmic structures. Small deviations in its properties could destabilize entire galaxies, sending planets drifting into chaos or triggering colossal collisions. Invisible forces often prove the deadliest, operating silently, imperceptibly, yet orchestrating the motion of stars, planets, and entire systems. Time is relentless, an unyielding predator. Stars burn, planets orbit precariously, and galaxies evolve. Entropy ensures that order decays into chaos. Even without sudden catastrophes, time guarantees extinction. The sun will eventually exhaust its fuel, expand into a red giant, and likely engulf the inner planets. Stars fade, galaxies drift apart, and the universe continues its indifferent march. Time's danger is patient, inevitable, and absolute no life form can withstand it forever. Rogue celestial objects inject chaos into the cosmic order. Wandering planets, stars, or black holes can intrude into stable systems, destabilizing orbits and triggering collisions. Minor gravitational shifts can have catastrophic consequences over millennia. The universe's hazards operate across scales and energies far beyond human comprehension. Life survives not because of stability, but in spite of the chaos, navigating improbable alignments that favor survival. Life itself is a fragile triumph. Earth exists because countless conditions align: orbit in the habitable zone, protective, magnetic field, tectonic stability, and chemical composition. Even minor deviations could render the planet sterile. Life has endured asteroid impacts, supervolcanic eruptions, climate shifts, and mass extinctions. Humanity is a brief spark of consciousness in an indifferent cosmos. Our survival is extraordinary, improbable, and fleeting. At the microscopic scale, danger persists. Strangelets, quark matter, and hypothetical exotic particles could trigger chain reactions that convert ordinary matter into fundamentally different forms. Quantum fluctuations and vacuum decay may propagate at light speed, annihilating all matter. Some of the deadliest cosmic forces are invisible, operating beyond observation, yet capable of reshaping reality on the grandest scales. Even our most secure understanding cannot fully account for these hazards. Yet humanity endures. Knowledge becomes both shield and instrument. We track near-Earth objects, measure gamma-ray bursts, observe black holes, and theorize about dark energy and dark matter. Understanding mitigates risk but does not alter the universe's indifference. Survival is temporary, a defiance against forces that could obliterate existence instantaneously. Every discovery, every observation, every act of creation is a triumph over overwhelming odds. The universe is indifferent. Catastrophes do not discriminate. Black holes consume relentlessly. Gamma bursts strike without warning. Time marches onward. Survival is uncertain. Every conscious moment, every thought, every act of creation is a victory against forces that could erase existence in an instant. Life persists not because the universe favors it, but because survival is improbable. Humanity observes, reflects, and persists, despite forces beyond comprehension. Within this peril exists wonder. Life thrives. Consciousness emerges. Knowledge grows. Stars illuminate the void. Galaxies collide in violent elegance, and planets nurture intricate ecosystems. Danger and beauty coexist. Survival is extraordinary precisely because it is improbable. Consciousness itself is miraculous in an indifferent universe. Humanity's story, brief and fragile, is a testament to resilience and chance. The universe's hazards are manifold. Gamma-ray bursts, black holes, magnetars, quantum fluctuations, and the patient march of time. These forces shape the fate of worlds and civilizations without intention. Every cosmic event reminds us of fragility, impermanence, and the narrow corridor of survival. Survival relies on awareness, preparation, and improbable alignment. Humanity exists, observes, and reflects, creating meaning amidst chaos. Ultimately, the most dangerous entity is the universe itself, infinite, indifferent, and relentless. Its forces could annihilate everything in moments or eons. Yet life emerges, consciousness arises, knowledge grows, humanity survives, observes, and contemplates. Exploration, understanding, and awareness are miracles against a cosmos that offers no protection. In this perilous reality lies both terror and beauty. Stars burn, galaxies collide, black holes consume. Gamma-ray bursts streak across the void, and time moves relentlessly forward. Life endures against unimaginable odds. Humanity, small and fleeting, persists, observes, and imagines. Every act of awareness is a triumph against forces that could erase existence. Consciousness emerges amidst catastrophe, and knowledge flourishes despite danger. The universe teaches humility. Its dangers are omnipresent and absolute. Life survives not because of benevolence, but because of improbable alignment of conditions and chance. Every heartbeat, thought, and observation is a miracle. Survival is fleeting yet extraordinary. Wonder exists because danger exists. Beauty arises in a universe unconcerned with existence. Humanity's story is remarkable precisely because it confronts a universe filled with peril, and in the end, perhaps the greatest danger is the very same source of life, creativity, and consciousness, the universe itself, infinite, indifferent, unpredictable, and relentless. Every star, black hole, and cosmic phenomenon is both a threat and a source of awe. Humanity persists, observes, and dreams in defiance of this vast, uncaring expanse. Consciousness and survival are miracles against incomprehensible odds. The universe will continue vast, silent, merciless, and magnificent. Stars will form and die, galaxies will collide, black holes will consume, and gamma-ray bursts will flare. Life may endure for a fleeting moment, only to be extinguished. But in that moment, consciousness exists. Awareness arises. Knowledge flourishes. Humanity, a brief spark in a cosmic storm, persists, contemplates, and wonders. And in that persistence, amidst danger, the universe itself is rendered meaningful.